Good afternoon, everybody. We have to be start one of the important things related to the your career, that is GATE exam, right? GATE indicate that graduate aptitude test exam. We have dealing the things related to the GATE of the 2023, right? So for that purpose, we have to be design the one of the thing, that is we have discussing the thing related to the electronic subject, that is analog and digital integrated circuit, right? This is the subject for you. Whatever the content of it that I am explaining, then we have to be start the whatever the thing that in that chapter, right? See, analog and digital electronic syllabus. See, in that syllabus, whatever thing you have studied in a second year and the third year, that is related to the that are not related to the microprocessor, microcontroller, but the things which are required for your future career. That's why the thing which are discussed here is simple diode circuit. Simple diode circuit indicate that the circuits such as clipper, clamper, that's another circuit, that is a rectifier, right? In that circuit we have to use the diode. This is nothing but a simple diode circuit. Okay, so in that circuit the question asked on that topic is not only the theory, that also part of the problem, some small problem that should be asked with respect to simple diode circuit. After all, we have seen the clipping and clamping. Now, what do you mean by clipping? What do you mean by clamping? That we have to be discussed. We just discussed the introductory thing related to the syllabus. Clipping indicate that some part of output which should be clipping indicate that it should be divided, right? Or it should be eliminated. That is nothing but a clipping of the particular voltage or the current, right? Clipping indicate that whatever part we have recorded, that only passes over the network and other part should be eliminated. This is nothing but a clipping, right? This is required for the purpose of the application of clipping. I'm telling you the application of clipping is rectifier. Rectifier is the application of clipping. In that we have to be remove the second part, that is I'm telling with respect to pulsating rectifier, because output of your rectifier is a pulsating DC, it is not a pure DC. So pulsating DC output is the example of clipping of negative half cycle. Okay, this is the thing with respect to clipping. Clamping, see some of the application where we have required the whatever the voltage or current, that should be increasing certain level or decreasing certain level, means upper means zero, upper to the zero level or lower below the zero level. In that case we have to use the clamping circuit, right? This circuit should be increase or decrease the level of whatever the voltage applied across it. This is nothing but a clamping. Then rectifier, you know that rectifier indicates that it is the device, it is the device which should convert the AC voltage into the DC voltage, that is called as rectifier. Now see, according to our need, we have to use the three different type of the rectifier. One is your half wave rectifier. Basically it have only two types, that is a half wave rectifier and the full wave rectifier. Okay, so half wave rectifier indicate that it have only single diode is used for the conversion of AC into the DC. One of the greatest disadvantages of half wave rectifier is that it have maximum ripple. Ripple indicate, I'm telling you what is the definition of ripple. Ripple indicate that unwanted AC part, right? Unwanted AC part, that should be more in case of your half wave rectifier. Then another type is a full wave rectifier. See, full wave rectifier means it is the rectifier which should be work in a two half cycle, that is positive and negative half cycle of the AC, right? See, there are two type of the full wave rectifier. One is full wave bridge type rectifier, full wave center type rectifier. These are the rectifier in which type of the transformer should be used, right? We know that in case of transformer, bridge type have and center type have different type of the transformer used. Center type have three wire transformer, means it have two input, that is a that should be connected to the input part, and two, three for the output. Center tap is used, that is in case of center tap rectifier. And in case of bridge, normal two wire at input, two wire at output, that is used. These are the two types of the center tap and bridge type rectifier. The question asked on GATE on the topic is such a way that in which type of the rectifier configuration used in a industrial application, right? In which type of the rectifier configuration in the industrial application? Okay, the reason,
आपे पडलेत. अनिल परबांच्या
is
कथित
of the
बंगल्यावर
mind.
कारवाई झाली. इतकंच काय तर महाविकास आघाडीशी संबंधित अनेकांची चौकशी सुरू आहे. मुंबई महापालिकेचे स्थायी समितीचे अध्यक्ष आणि मातोश्रीचे जवळचे समजले जाणारे यशवंत जाधव यांच्यावर इन्कम टॅक्स.
See, normally there are two types of the rectifier, that is basically half-wave and full-wave, but full-wave have two, that is center tap and bridge. See, center tap transformer, if we have to use the conversion of AC to DC, one of the disadvantages of it, whatever the noise coming, see, whatever the noise coming, that is more. Why it is more, I'm telling you. In case of center tap rectifier, we have to use the two diode for the conversion of AC to DC, right? For that purposes, whatever the input coming from your AC, that should be coming to the DC, that should be processed by only single diode at a time, right? That's why it have more noise. But in case of fully bridge rectifier, it have bridge of 4 diode is used, so that at a time 2 diode should be worked. That's why the whatever the noise in case of your fully bridge type rectifier, it is less than that of your folio center type of the rectifier. That's why folio bridge type configuration used in more in industrial as well as day-to-day application. That is the reason behind it is. Okay. Then we have seen that amplifier. So you know about the amplifier. What do you mean by amplifier? See, I'm taking the one of the example of amplifier. See, when you have to be on your classroom, right? The size of the classroom is very large, means there should be 200 or more person should be on that class, right? In that time, what happen, whatever the teacher are telling you, that should not be got at last, right? So that's why they have to use the mic and the amplifier configuration, right? So what it does, mic, what it does, so whatever the input means, whatever the I'm telling, that should be attached with your mic should be attached to the another part, that is amplifier, right? So amplifier, what it does, whatever the input applied, input indicate that I'm telling something, that is a within a small sound, right? That should be connected to the amplifier. So amplifier, what it does, whatever the input coming across it, that should be amplified. Amplify indicate that it doesn't change the signal, it doesn't change, it should be changed only the whatever the things, means whatever the quality of it doesn't change any quality of the voice, it should be changes strength of the input, right? That's why amplifier used for the increasing the strength of the input signal, right? So for that purposes, amplifier is, there are different configuration of amplifier. Normally I'm telling you which are the configuration: class A, class B, then class AB and class C, and then new type of the amplifier, that is digital amplifier, one of the new, that should have used small pulses. These are the type of the amplifier. So that should be, means according to your need. Normally class A type of the amplifier is the we have seen the detailed thing in a next, but there are normally class A, class AB, class B, then class C, and the digital amplifier. These are the type of the amplifier. These are used according to their need. We have to be seen the detail of it in further lecture. Then biasing. Now see, biasing means what? See, applying voltage to the particular terminal of the device, that is nothing but a biasing, right? Biasing indicate that we have only applying the voltage to the device to work in a particular condition, that is nothing but a biasing. Why we need of the biasing? What are the uses of biasing? That we have to be seen in a detail, right? Then equivalent circuit and frequency response. Now see, when we have to be seen the amplifier, in that case, amplifier, when we have to use the different configuration, it have its equivalent diagram. Why equivalent? Because it have input impedance, output impedance, right? That thing are changes according to different configuration, right? This is the analysis with this analysis is nothing but a equivalent circuit and frequency response of the amplifier. Then we have seen that one of the important thing, amplifier and oscillator. I'm telling you, these are not different, but some of the thing which are different with respect to it, means amplifier indicate what it does. See, with respect to feedback, I'm telling you the thing with respect to amplifier and oscillator, that is related to the feedback. Feedback is nothing but a what do you mean by feedback? That I'm telling you, some part of output is again applied to the input. This is nothing but a feedback, right? So in case of amplifier, see, in case of your amplifier, there should be use of the negative feedback. negative feedback. So one another disadvantages of negative feedback is that when we have to use the negative feedback, whatever the gain of your amplifier, that should be reduces. See, why we design the amplifier? Anyone tell me why we design the amplifier? I'm telling you already why we design the amplifier. Swapnil Kamble, please tell me why we need of the amplifier. Suraj Dudha, why we need of the amplifier? See, the reason is why we have to be use the amplifier. The reason behind it is, I'm already told you, if the voice of particular thing is not going so long period, right? For that purpose, what we have to do, we have to be use the amplifier. Amplify that signal means strength of the signal. So that's why that should be going to the more and more distance, right? This is the use of the amplifier, right? In case of amplifier, we have to be use the negative feedback. Negative feedback means part of output is again applied to the input, but whatever the output applied, that is phase shifted, right? That's why this is called as negative feedback. So negative feedback is used in amplifier. So when negative feedback used in amplifier, what happens? See, when negative feedback used in amplifier, it reduces the gain of amplifier, but if it is reduced, this is not acceptable in case of amplifier, because we have designed the amplifier only reason when it is to increase the strength of the input. But when we have to use the negative feedback, it reduces the gain. But one of the important thing happen in this case, it reduces the gain, but it stabilizes the gain. Stabilizes means it does not vary, right? That's why in case of your amplifier, we have to use the negative feedback. Then we have discussed with respect to oscillator, right? In case of oscillator, we have to use the positive feedback. Positive, see what do you mean by negative and positive feedback? See, positive feedback indicate that input and output in same phase, right? That is called as positive feedback. If input and output have different thing, means 180-degree phase shift. म्हणजे जर आपण see, if we have to be use the input have sine wave, right? Input have sine wave and output have cos wave. What it indicate that there should be 180-degree phase shift, right? This is called as negative feedback. Means some part of that negative feedback signal means if we have to be apply sine wave, we got the cos wave. Again, that cos wave is applied to the input. It indicates that negative feedback. If we have applied the sine wave, we got the sine wave, and that sine wave is again applied to the input. This is called as positive feedback. So that positive type of the feedback used in an oscillator. The application of oscillator is that it should be used for the sine wave generator. Sine wave signal generation, we have to be used the oscillator amplifier to increase the input signal strength. That's why this is the application of your amplifier. Okay, feedback amplifier. Now see, feedback, I'm telling you, feedback amplifier, according to their amplifier, there are different type of the means how we have to be add the feedback to the amplifier. It have 4 type of the particular oscillator configuration that we have to be seen in detail in further lecture. Operational amplifier. Now see what do you mean by operational amplifier. See, operational amplifier indicate that IC741 that you have to be study in a ADIC subject, that is second year second sem subject, right? OPM indicate that operational amplifier, it is also called as IC741, right? This is used for the particular means in amplifier configuration we have required the different other devices, that is your transistor, then resistor, right? All other material required for the different configuration. But OPM is a actually designed device which should be directly used as an amplifier, right? Operational amplifier, we have to be used as an amplifier, minimum number of the component that should be used. There are different application of the operational amplifier, normally inverter, then converter, as well as increasing the gain of the signal. Then there are so many type of the operational amplifier application. There are actually specifically 2 configuration operation of the operational amplifier. One is inverting amplifier and other is non-inverting amplifier, right? So inverting amplifier means what? We have, when we have to be apply the input to the there are two terminals with respect to transistor, that is inverting and non-inverting, right? When we have applied the input to the inverting, in that case, whatever input applied, that should be 180-degree phase shift, right? When we have to apply the input to the non-inverting terminal, whatever the input applied, that should be coming with respect to output, only strength of the signal is increased. Okay. These are the application of the op-amp. There are so many application in the op-amp. Single stage active filter. Now see, filter indicate what? See, if you have to be seen that in some talkies, that is a cinema talkies, in that case, when you have to be go in that place, there is a bar of your mobile phone, right? It is means whatever the signal of the mobile, that should not be coming. In that case, they have to use the filter, which should be eliminate the mobile signal coming over there, right? In that case, they have to be use the filter, right? These are the things with respect to the filter. Then there are different Allen key, Butterworth, VCO indicate that voltage controller oscillator, and timer indicate that normally timer IC, it is used for the timing, different timing IC, different timing thing control, right? Timer used any place for the purpose of controlling the signal timing, right? Then we have seen the combinational and sequential logic circuit. Now see, tell me which are the combinational and sequential logic circuit. Example of combinational and the sequential logic circuit. Any don't know about the what is meant by combinational, what is meant by sequential? See, output of one is connected to the other. This is called as sequential logic circuit. But in case of combinational logic circuit, this is not happen. Means in case of sequential logic circuit, output of one device is connected to the another device, right? So what it indicates that one device should be depend on other, means output of first devices should be depend on the means performance of second depend on the output of first devices. But in combinational circuit, this is not happen, means different thing. If we, there should not be any relationship between your output of first stage to the second stage, right? This is called as combinational circuit. So when we have to be need of the output of one device is connected to the need of the output of one device is connected to the other, in that case, that is called as sequential. If the circuit which doesn't, means they are independent with respect to output of one device to the other, in that case, that circuit is called as combinational. Okay. Then we have seen that multiplexer, demultiplexer. Now see, multiplexer means many input, one output, that is called as multiplexer. Demultiplexer indicate that one input, multiple output, that is called as multiplexer. Okay. So concept of multiplexer and demultiplexer used in case of your telephone exchange, because see how it is, I'm telling you, all of the see there are 100% which should be living in a, consider 100% living in a campus of Surrey, right? If they have to be used the BSNL landline phone, consider BSNL landline phone. That's why this should, means all of the phones should be initially connected to the telephone exchange, right? Means if the person, any person calling to the certain person, in that case, whatever the call, that should be initially coming towards the telephone exchange, and telephone exchange divert to the call to the particular person, right? This is the example of the demultiplexing, right? Means one signal is, means any person initiate the call for particular person, that call going to the telephone exchange, right? Telephone exchange divert that call to the particular person, which is nothing but a demultiplexing operation. In case of multiplexing, what happen? Many person which should be access to the telephone exchange at a time, right? So in that case, telephone exchange, what does, all of the call connected and diverted to the different way, right? Means connected to the different way. This is called as multiplexing operation. The schemic trigger indicate that output of schemic trigger, it is also the one of the sine wave generator, right? Sine wave generator. Schemic trigger used for the generation of the sine wave signal for different application. Sample and hold circuit. See what do you mean by sample and hold circuit? We know that in today's world there should be many more use or drastic use of your digital system, right? But all of the environmental thing is not digital, right? So that what we have to do, initially when we have to be processing on any of the things, it must be digital, right? So initially it should be converted to the analog to digital, right? In that case, we have to be operating on it in some operation. So that's why in case of conversion of analog to digital, whatever the input applied, that should be sampled. Means sample indicate that part of that the analog signal, right? Part of that signal should be translated according to their level. You consider as a whatever the input applied, that should be in between your 0 to 10 volt. Consider if the range means whatever the input range in between 0 to 3 volt, it should be considered. It should be considered as a 0. The voltage which should be greater than 3, that should be considered as a 1, right? Accordingly, we have to use that. Means for that conversion, we have to use the circuit. That circuit is called as sample and hold circuit. Then A to D and D to E conversion. See, I'm telling you now, A to D indicate that analog to digital converter, and other is D to A converter. Now see, A to D converter indicate that for the application, for the different operation, we have need of the signal that should be digital. So for that purposes, consider as an example of pressure. See, some pressure which should be needed for analysis purposes, but pressure is analog thing, right? Pressure is analog thing. For our processing purpose, we have required that is as an digital. So that what we have to do, that analog pressure should be converted into the digital and transmitted over the wire, and then it should be processed. So that's why we have to use the analog to digital conversion. Okay, now see example of D to A conversion. See, D to A conversion means if we have to be working on any of the plant, right? Any of the plant, if consider as a whatever the consider as a pressure, right? Whatever the pressure of the particular devices, that should be converted into digital, and that should be traveling through the wire. Okay, wire, and that pressure should be used for the another devices indicator long distance devices, which should be depend on that pressure, so that whatever the device can across, they doesn't know the digital thing. So that's why to convey that message to the particular digital analog devices, because see, proper in a normal thing, all of the devices that should be analog, not a digital. Actual working should be done with respect to normally analog things, right? So that's why digital signal whatever traveled, that should be converted into again analog. In that case, D to A converter we have to be needed. This is the generalized thing with respect to your syllabus of your ADIC. Okay, see, we have to be start up the initial thing with respect to basic thing with respect to the rectifier. We know that rectifier indicate that rectifier is the device. This is the basic application of your diode. Okay, diode indicate that I'm telling you something related to the diode. There are normally basically two types of the diode. One is your PN junction diode, other is Zener diode. See, PN junction diode indicate that this is the diode used for the application of your rectification. So rectification is the basic operation. So why we need of the rectification, that I'm discussing you. Rectifier indicate that it is the device we should convert the AC voltage into the DC voltage. Now see, why we need of the DC, we have bulk amount of AC available from your MACB, right? Now MAC DCL, okay, bulk amount of AC available with respect to it. Also why we need of the DC, because we have bulk amount of AC, many more power in case of AC. It also we have to use the DC. Tell me the reason behind it is. Anyone please tell me. Class should be communicated. Please tell me why we need of the DC if we have to be bulk amount of AC available. Please give me response. Vikrant Gaikwad.
Some applications work on DC, so the DC power we need,
Right.
like TV, laptop.
No. Right. Your answer is right. See, but in case of laptop, what we have to do? We have to be connected the one of the devices. We doesn't direct connect AC to the laptop, right? One of the adapter, right? Adapter convert that AC to the DC. Is it right? Basically, we have
Yes, sir.
Basically we have connected AC to the power that should be connected to the one of the adapter. That adapter should convert the AC voltage into the DC, right? That's why we have to be need of the DC, right? Your answer. In also TV, also same thing. In case of TV, we have to be apply the AC voltage internally that should be applied to the particular EHT. EHT is nothing but extra high tension in an internal part of it. There should be use of the transformer. That transformer converter internally required voltage that should be converted again DC, that is more voltage, right? So in case of your TV also DC internally DC voltage is used. Another thing in a laboratory purposes that is not related to the electrical, because in a electrical laboratory there should be used of the high voltage, that is 230 smallest part for the electrical, because 440 more than that of voltage required, because power is the one of the important factor with respect to electrical, right? So that's why we require more and more power. But see, I'm telling you, in case of electronic devices, they have required the small power, and if that power have less fluctuation indicate that that should not be changes with respect to time. See, AC indicate that that is the voltage which changes with respect to time, either your positive cycle and negative cycle. In case of India, that is 50 Hz, means positive and negative cycle in 1 second 50 times. In case of America, tell me the frequency of America. 60 Hz is the frequency of America. Okay, see, for that purposes, whatever the electronic devices used for the different application, that doesn't need of the changing the voltage or the change in the voltage. So that's why we have to be convert the AC voltage into the DC. AC indicate that alternating current, DC indicate that direct current. Okay, so for that purposes we have to use the devices, that is rectifier. Rectifier is the device which should convert the AC voltage into the DC voltage. Okay, but whatever I'm telling, that is a near about right, because rectifier doesn't do the AC into DC. I'm telling you again, because it should be converted AC into the pulsating DC. That is the proper definition of your rectifier. Why it is? Because whatever the part coming across your output, when we have to use the rectifier, that is not a pure DC. It has some part of the AC. So some part of AC that should be called as pulsating DC. So rectifier is the device which should convert the AC voltage into the pulsating DC. That is the proper definition of rectifier. Okay, so there are different things used for the removing that pulsating component, that is filter, the regulator, that are the part used. According to your need, you have to use the particular configuration, that is a filter or the regulator. But in a normal application such as small kids vehicle or the small kids, whatever the device is used, in that case they have to be used the half wave type of the rectifier, because they doesn't need of the actually regulated output. Okay, basically we have seen that these three things only in this lecture, right? Which are that thing which we know that there are basically three type of the rectifier, basically two. One is half wave, other is full wave. But full wave also other two type, that is full wave bridge type rectifier and full wave center type rectifier. Okay, these are the three types. This is the half wave rectifier. In case of half wave rectifier, we have to be use the single diode, means conversion of AC to the DC, we have to be use the single diode. That's why whatever the efficiency coming with respect to, means pulsating component coming with respect to half wave rectifier, that is more, because only single diode used for the conversion of AC to the DC. And another thing, this diode indicate that anode is here, cathode is here. So this should be worked only one half cycle. Tell me in which half cycle this diode work. Please give me response. Either your negative half cycle or positive half cycle. See, this is the AC voltage, positive negative half cycle. Okay, this is anode, this is cathode, right? So we know that diode is only conducted when anode voltage is positive, right? So that's why during the first positive half cycle, diode should be conducted. When the half cycle, that is negative half cycle, is coming, it is a minus, it is a plus, so it is not worked. This is happen in case of your half wave rectifier. So that's why output coming with respect to half wave rectifier, that is less, because we have, if we consider, if we have applied the 10 cycle, right? 10 cycle indicate that positive as well as negative half cycle. Only 5 means only 5 positive half cycle means whatever the output coming, that should be 50%, right? This is coming with respect to half wave rectifier. And another thing, we've seen that other rectifier, that is full wave rectifier, it is also called as full wave center type rectifier, right? In this case, we have to be use the center tap for the transformer. See, another thing with respect to this type of the transformer is that the cost of this means two input to output transformer, cost of two input to output transformer and cost of the two input and three output transformer, that should be different. Means if consider as the cost of the two input to output transformer, it is a 50. In that case, this have the cost of the 70. Cost is more in case of your folio center type of the rectifier, because up whatever the upward voltage, that should be exactly opposite to the lower. See, in this case, consider as we have applied. See, we have applied the 230 volt. Accordingly, consider as this is the 12 volt. 12 volt transformer, right? So this is a 12, this is a 0, this is a 12, right? 12 or 0, 12. This is also called as center type of the transformer. Okay, so for the purpose of your center type configuration, we have required the center type transformer. So cost of the configuration, that should be increases. And another thing, see, when we have to be center type transformer is used, output is not pure, means compared to the folio bridge, output is not means more noise compared to the bridge type of the configuration, right? Another thing we have seen that with respect to folio center type rectifier is that in case of center type, only two diode is required, only two diode is required. So that is the only some of the advantages thing. Okay, but disadvantages thing is that due to that only two diode, only one is used at the particular time. So that's why it have more noise. Noise indicate that AC component is more in case of your output. Now we have seen that bridge type of the rectifier. Bridge type of the rectifier, what it indicate that it is the rectifier. We have to be use the bridge of 4 diode for the conversion of AC voltage into the DC. That's why it is called as bridge type rectifier. Okay, whatever the transformer used across it, primary have the 2 wire, secondary have the 2 wire. That's why it is a bridge type of the configuration. Okay, see, these are the two input applied across it. We have seen the detail of it in a session. See only here, in case of bridge type configuration, we have to use the 4 diode, and at a time means when the positive, either your positive half cycle or negative half cycle, 2 diode work at a time, one for upper and other is for lower. Means positive has a 1 diode and non-negative has a 1 diode, so that 2 diode working at a time. So that's why output coming across it is a less noisy than that of your center type configuration. Okay, just outline of this lecture. See, we have seen the introductory thing with respect to this. Rectifier indicate that it is the devices which should be convert the AC voltage into the DC voltage. Okay, so to convert the AC voltage into the DC, what we have to do? We have applied the direct AC voltage. We have to be use the direct diode for that configuration according to our need. See, and the current rating. Normally, I'm telling you just example of the one of the diode 1N1001. These are the one of the particular number of the diode. In that case, what it indicate that this is the diode which should be used up to the last one, indicate that up to the 1 ampere voltage, right? So 1N1001, it is the one of the diode configuration which is used up to the range of the 1 ampere, means maximum current through that diode is 1 ampere. Voltage is near about the 10 to 15 volt. Okay, so see, direct current, AC and DC, we have discussed the AC and DC. AC indicate that alternating current. Alternating current indicate that it have two half cycle. Two half cycle indicate that positive and negative half cycle. Okay, so that should be happen each and every time during the 50 times in a 1 second. Okay, then we have seen that DC indicate that direct current indicate that it doesn't changes with respect to time, right? But what we have to be used in case of rectifier, means whatever the output coming across your rectifier, that is not a pure DC, it is a pulsating DC. These are the things with respect to the rectification. So rectification indicate that it should be the device which should be converted AC voltage into the DC voltage. DC indicate that direct current which should not be changes with respect to time. Okay, but in case of pulsating DC, this is not happen. It should be some of the changes. So for that removing part changes, we have to be use the different thing with respect to regulator as well as the filter circuit for it. These are the introduction of the rectifier. You see types of rectifier, half wave rectifier, full wave rectifier, that are only the type of the rectifier. But see, when we have to be discuss types of the rectifier, in that case we have to be telling as a half wave rectifier and full wave rectifier only. But when we have to be added the other thing of the rectifier, that is bridge rectifier. So full wave rectifier indicate that in this case folio center type rectifier. Okay, so basically there are two type of rectifier, half wave and folio, but folio have also two type, that is folio rectifier, it indicate that center type, and folio bridge type, it is the another type of the rectifier according to our need. Means whatever the noise level that should be more or less required, accordingly we have to use the different type of the configuration. See, cost of the equipment is less, in that case we have to use the half wave rectifier. If the instrument and the whatever the application that is a sophisticated, in that case we have to use the folio bridge type configuration, not a folio rectifier, that is center type of the configuration, because it have noise is more, right? If the noise is requirement less, so in that case we have to use the bridge type configuration of the rectifier. See, half wave rectifier, just introduce because time for that particular is less. See, half wave rectifier indicate that it is the rectifier which should be converted either your positive or negative half cycle. See, rectifier indicate that it should not only eliminate the negative half cycle. We have also connected diode opposite way. In that case, it also eliminate the positive part also. Means if we have to be connected the diode, see the diagram. Here is one of the diagram. See, this is the diagram. This is the positive half wave rectifier, right? Each positive half wave rectifier indicate that it have only positive half cycle coming with respect to output. If it is connected opposite way, in that case, this is called as negative half wave rectifier, right? Means which half cycle should be eliminated, that should be connected opposite way. That is the thing with respect to the half wave rectifier. See, efficiency of half wave rectifier is less because only single diode used for the two half cycle, and the only either your positive cycle or negative half cycle is eliminated. The reason that it is only single diode is used. It should be used in either your positive cycle or negative half cycle, because when it should be connected in this way indicate that positive, in this way, in that case positive half cycle coming with respect to output. If it is connected opposite way, in that case only negative half cycle is coming with respect to your output. See, this is the thing with respect to half wave rectifier. See, this is the input AC supply applied to the rectifier, right? So when it is applied to the rectifier during the first positive half cycle, see, during the first positive cycle, consider, see, diode have the two material used for the construction of diode. One is silicon. See, small question asked in a exam. One is silicon and another is germanium. See, cut-in voltage. Cut-in voltage for the silicon diode is a 0.7. For the germanium, it is a 0.3. Okay. So accordingly, this should be considered as a ideal. Ideal indicate that if whatever the input voltage applied, that should be more than 0. It should be conducted. Okay. So this is the anode is here, cathode is here. So during the first positive cycle, it should be conducted. So positive cycle appear across output because diode is ideal. Okay. So during the next half cycle, that is during negative half cycle, what it does during the negative half cycle, whatever the input voltage that should be coming with respect to this diode. So what happened? This diode is not conducted. It is going on to reverse bias. Why it is? Because anode have applied the negative voltage, that is reverse voltage. So due to the application of reverse voltage, it is not conducted. So negative half cycle is not coming across your output. Again, positive half cycle is coming with respect to input. That should be passes over this diode, and we have got the positive half cycle with respect to your output. This is the thing with respect to the half wave rectifier. See how we have to be calculate the output of DC voltage. See, it is a 50%. Means if we have applied the voltage, any voltage, There should be 50%, it should be coming with respect to output. The reason behind it is only either your positive or negative upcycle should be coming with respect to your output. So efficiency of half wave rectifier, that is very less. That is a phi peak by 2. PRMS means it is the voltage which should be coming with respect to your half wave rectifier, that is phi peak by 2. That is 50% voltage which should be coming with respect to the half wave rectifier. With respect to RMS, with respect to DC voltage. Now see, full wave rectification. Now see, there are two full wave rectification configuration. One is your full wave bridge type and full wave center type of the configuration. In case of your full wave, we have to be full wave bridge type, we have to be use the 4 diode. In case of center type, we have to be use the 2 diode. According to they have to be diode user, they have two types of the configuration, that is center type and bridge. In case of center type transformer, see, in case of center type configuration, we have to use the center type of the transformer. Okay, in case of bridge, normal transformer is used. See, full wave rectifier using transformer and 2 diode. This is nothing but a center type of the configuration. See, I just explain the things. This is the AC voltage. AC voltage is applied across your input of the transformer. You are the electrical students, so that's why no need of the telling the thing of the transformer. Transformer is the device which should convert the AC voltage into the AC, right? Either it is a low to high or high to low, right? So in this case, high voltage into the low voltage. So that's why it is called as step down type of the transformer. Okay, so this is the step down type of the transformer. See, normally what happen in case of step down? Actually, this is not a step down. How it is? Tell me. Diagram on it is, according to the diagram, it doesn't show that it is a step down. How it is? Tell me. According to the diagram, it doesn't tell that it is a step down. Why it is? Tell me. It is step down, but means we have seen the thing with respect to the step down, because rectifier, how we have to be whatever the voltage applied, it is a 213 here, maybe 12 volt or the 14 or the 20 volt. Tell me why it is not like as your step down. Tell me which are the thing coming with respect to step down that should not be here. See, Anil Kamble, please tell me. With respect to, I'm given you one of the hint, that is with respect to your transformer. See the diagram of the transformer. Tell me.
Don't know, sir.
Huh?
Don't know.
With respect to winding, see the winding. Primary have 3 windings, secondary have 3 windings. What it indicate? That 1:1 ratio. Okay, 1:1 ratio. What it indicate? That 230 is applied or 230 is coming across your output. Is it correct? Is it correct? See, particular conversion with respect to winding. Okay, according to this winding, it should be normally primary have the high winding, secondary have the low winding. Why? Because it, see, the connection between primary to the secondary, is it direct or indirect? Tell me. Please tell me. The connection between primary to the secondary, it is a direct or indirect, or which type of the connection between primary to the secondary? Please tell me. See, this is wrong thing with respect to this diagram, is that 3 have input winding, 3 have output. It indicates that it is a 1:1 ratio, right? So it is not acting as a which type of the transformer? Which type of the transformer? Tell me. Please, I'm already told you related to this. There are 2 configuration of the transformer. Which are that? low to high and high to low. Now tell me. Step up and step down. Okay, this is not like as a step up or step down. It should be as like as one to one configuration, because 3 have input winding, 3 have output winding. Okay, so in case of step down, primary have the whatever the winding coming with respect to secondary, that is less, right, when it is a step down. Okay, so that's why actually, but this is actually step down type of the transformer, and the connection between primary to the secondary, it is not direct, it is a flux linkage. See, connection between primary to secondary, it is not directly, means wire not connected to each other. There should be flux linkage between primary to the secondary. Okay, see, input is applied across this to 30 volt voltage is applied across it. There should be generation of, consider as a 12 volt output with respect to this. So this 12 volt is applied to the diode. Now see, during the first positive cycle, plus is here, minus is here, plus is here, minus is here. So plus voltage is coming across diode D1 and minus voltage is appear across your D2, right? So according to the whatever the operation of your diode, when the anode is positive of the D1 and the anode is negative of the D2, so anode is positive of D1, so it should be conducted. So diode you consider as ideal. So this positive cycle is coming across your output. Okay, now with respect to negative half cycle, now see, whatever the input applied across it, it is a reversed. So whatever the voltage is coming across it is, that is also reversed. Okay, so plus minus, that should be reversed by minus plus. See, minus plus minus plus. Okay, so reverse voltage is appear across your diode, so it not be conducted now. Okay, now see, here minus plus minus plus, positive voltage is appear across your diode D2, right? Due to that positive voltage, it should be conducted. So that's why what happened, this voltage is coming across here, so that's why we have got the positive output across your output. Okay, positive. This is the happen during the next half cycle, that is a positive half cycle. During that positive half cycle, again plus is upper, minus plus minus. During that diode D1 is conducted, whatever the output coming, that is a positive with respect to this third half cycle, that is also positive. Means either you are a positive half cycle or negative half cycle, that should not be affected the performance of your center tap type of the configuration. According to the need, see, according to need, what it indicate that during the positive half cycle, diode D1 is conducted, during the negative half cycle, diode D2 is conducted, and we got the output, that is a positive. It is also called as pulsating DC type of the output. Why it is called as pulsating DC? Because whatever the output coming, that should not be pure DC, it should have some of the part of AC. See, this positive part, that's why it is called as pulsating DC. Now we have seen that another type of the rectification, that is a folio type of the rectification. It is also called as folio bridge type of the configuration, right? Why it is called as bridge? See, in that case, we have to use the bridge of the 4 diode for the conversion of AC voltage into the DC. That's why it is called as folio bridge type of the configuration. Okay. Another advantageous thing with respect to this type of the configuration is, at a time 2 diodes should be worked for the positive as well as negative. So that's why noise indicate that unwanted DC, it is, sorry, unwanted AC, it is called as noise. So that's why at a time 2 diodes worked, so unwanted AC is less in case of your folio bridge type of the configuration. I'm telling you the working of this type of the configuration. See, this is the 230 volt AC voltages, 230 volt AC with 5 ampere is applied across your primary of your transformer. Accordingly, consider as a 12-0 transformer should be used over here. Okay, so accordingly 12 volt is generated across here. Okay, 12 volt that should be applied to the this portion, right? Positive is connected to the this portion, negative is connected to the here. Okay, so due to this positive voltage is connected across here, there are 2 diode connected to this node. Okay, one is considered as a diode D1, this diode is considered as a D2. Okay, so due to that positive voltage, what happened, this diode means anode of this diode is connected across here, so that positive voltage causes this diode should be worked. Okay, so that's why positive voltage is coming across here. Here another way, here is the one way, other is here way, but in this case diode connected in a opposite way, that is cathode is upper level, so that's why it is not conducted. So positive voltage is coming across here, and that should be coming across your output during the first positive half cycle. Okay, see during the negative half cycle, see what it indicate that AC how the two half cycle, that is positive and negative. Now see during this negative half cycle, this negative half cycle input is coming across here, that is a minus, and the plus is coming across here. So reverse voltage is coming across here. Minus indicate that now whatever the diode conducted already, that is D1 is not conducted. Why it is? Because reverse voltage is appear across it. So minus is coming across here. Now D1 is not conducted. This diode should be conducted because cathode of it coming across here. At the same time, here is another, that is plus voltage is coming across here. So plus voltage causes already conducting diode. This is the diode which should be conducted already, right? Sorry, this is the diode which we have to be plus voltage is coming across here. So during this plus voltage, what happened? This is not conducted, only this diode is conducted, so positive voltage is coming across here. Further negative voltage, it should be coming across here. Okay, so either your positive half cycle or negative half cycle should be coming, we got the output. Okay, this is the positive voltage. So that's why in case of your polio bridge or polio center type, whatever the input applied, that is a positive, it have positive or negative half cycle, there should be positive voltage is coming with respect to your output. Okay, this is the thing happen with respect to rectification operation. Any problem related to half-wave, polio bridge, polio center tap, please tell me. Please tell me any problem related to whatever the configuration I'm telling you. See, we have seen the formula for the particular conversion. That is a conversion as well as the for the calculation of different thing. Okay. Normally there are three things: half-wave, polio bridge, polio center tape. According to we have seen the formula for that particular thing. See, the average and root mean square output voltage of the ideal single phase polio rectifier. Polio rectifier. This is nothing but a VDC equal to VAV twice Vp by pi. Vp indicates the peak voltage. Okay, this is formula for the calculation of DC voltage of the polio rectifier. This is the output voltage. Okay, should be coming with respect to the polio rectifier, either your center tap or the bridge. Okay. We know that for diode used in a bridge type configuration. We have seen the thing with respect to bridge. See how it is work on at a time only two diode work now. We have generated output accordingly. That should be animated here. Means how the positive half cycle or negative half cycle accordingly only two diode upper two or lower two. That should be work. Okay, any problem on this bridge or the center tap or the rectification? Anything related to the rectification? No problem related to the rectifier. Give me attendance. Roll number 1.
Present.
Okay. 2,
Present, sir.
3, 4,
Present, sir.
5,
Present, sir.
6, 7,
Present, sir.
8,
Present, sir.
9,
Present, sir.
10, 11, 12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16,
Present, sir.
17, 18, 19, 20,
Present, sir.
21, 22, 23,
Present, sir.
23, 24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27, 28, 29,
Present, sir.
30,
Present, sir.
31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43,
Present, sir.
44,
Yes, sir.
45, 46,
Yes, sir.
47, 48, 49,
Present, sir.
50, 51,
Present, sir.
52, 53, 54, 55,
53 present.
okay, 53 present, okay, 55,
Yes, sir.
56,
Present, sir.
57,
Present, sir.
58,
Present, sir.
59, 60, 61,
Present.
62, 63, 64,
Present, sir.
65,
Present, sir.
66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 77 पर्यंत आहेत ना 77 ना लास्ट
नाही सर 74 लास्ट आहे
ओके 70 स्टॉप हिअर
41 present, sir.
41 ओके
Sir, 40 present.
40 प्रेझेंट